Mysteries of the Universe, A Journey Through Space. 2025 documentary. From the vast infinite expanse of the cosmos, we gaze back at Earth, a fragile blue gem suspended in the void. For centuries we have gazed at the stars with wonder, seeking answers to the profound questions that arise when we contemplate the universe. How did it all begin? What lies beyond the stars? Are we alone in the cosmos? Welcome to Mysteries of the Universe, A Journey Through Space. 2025 documentary that will take you on a grand voyage through time and space, unveiling the awe-inspiring and enigmatic wonders of the cosmos. From the fiery core of our solar system to the distant edges of the observable universe, we will dive deep into the celestial bodies that populate the vastness of space. This is a journey into the unknown, one that stretches the boundaries of human knowledge and imagination. Our story begins with our very own solar system, a relatively tiny region within the universe, yet one that holds incredible beauty, complexity, and mystery. Join us as we embark on this spectacular voyage, uncovering the wonders of planets, stars, galaxies, black holes, and more. The Sun, the powerhouse of the solar system. The Sun, our closest star, the powerful engine that drives the forces of nature within our solar system. Without it, life as we know it would not exist. It is both our source of light and our source of life. But what is the true nature of the Sun? And how does its immense power shape everything in our solar system? At the heart of the Sun lies a process of nuclear fusion, where hydrogen atoms collide with such force that they fuse to form helium, releasing an enormous amount of energy. This energy powers the Sun and radiates outward, creating light, warmth, and life-sustaining energy. The core of the Sun reaches an astonishing temperature of 27 million degrees Fahrenheit, 15 million degrees Celsius, a temperature hot enough to turn hydrogen into helium and produce enough energy to power the entire solar system. Despite its immense power, the Sun is classified as an average star. Its size is massive. It could fit more than 1 million Earths within its volume. Yet, in comparison to other stars in the universe, it's relatively small. Even though the Sun is considered to be middle-aged, it still has about 5 billion years left before it reaches the end of its life cycle. In approximately 5 billion years, it will enter the red giant phase, expanding enormously and potentially swallowing the inner planets, including Earth. Beyond the visible light we see, the Sun's influence extends far into the reaches of the solar system. The solar wind, a continuous stream of charged particles, flows outward from the Sun at a speed of around 1 million miles per hour, carrying with it the Sun's magnetic field. This constant barrage of particles impacts the entire solar system, sculpting the tails of comets and contributing to the auroras that light up Earth's polar skies. As we study the Sun, we gain a deeper understanding of the forces that govern not just our solar system, but the very nature of stars across the universe. Next, we move to Earth, the only known planet in the universe capable of sustaining life. From space, Earth appears as a fragile, shimmering orb, surrounded by a thin blue atmosphere that shields it from the harshness of the cosmos. Earth is unique in many ways, but it's its habitable conditions that make it so extraordinary. Earth is located in the Goldilocks zone, the region around the Sun where temperatures are just right for liquid water to exist. Not too hot, not too cold. Water, the key ingredient for life, is abundant on Earth, covering around 71% of its surface. This liquid water flows in oceans, rivers, and lakes, supporting a dazzling variety of life forms. But what makes Earth even more special is its atmosphere, composed primarily of nitrogen, 78%, and oxygen, 21%. This delicate mix of gases provides the oxygen we breathe, protects us from harmful solar radiation, and keeps our planet at an average temperature of 59 degrees Fahrenheit, 15 degrees Celsius, a comfortable climate for life to flourish. Unlike Venus, which is smothered by an incredibly thick, toxic atmosphere, or Mars, with its thin, inhospitable air, Earth's atmosphere is an intricate balance of gases that creates the perfect conditions for life. Our planet's magnetic field, generated by the motion of molten iron and nickel in the outer core, acts as a protective shield against the solar wind, which could otherwise strip away our atmosphere. The planet's surface is diverse and teeming with life, from the deepest ocean trenches to the highest mountain peaks. The biosphere, the layer of life that covers the Earth, is a thin veil, yet it has evolved over billions of years into an interconnected web of ecosystems. Earth is a planet defined by its diversity, its rich tapestry of life, and its complex geological history. However, Earth is also an incredibly fragile world. Its ecosystems are under threat due to human activity, and the search for other planets with similar conditions, planets that might harbor life, is a key focus of ongoing scientific research. Could we find another Earth-like planet in the vastness of space? This is a question that will continue to drive the future of space exploration. As we leave Earth behind, we venture into the outer reaches of the solar system, where two of the most awe-inspiring planets reside, Jupiter and Saturn. Jupiter, the king of the planets first. We arrive at Jupiter, the largest planet in the solar system, a gas giant that dwarfs all others. Jupiter's size is staggering. It's so massive that it could fit 1,300 Earths inside it. Yet, despite its enormity, Jupiter is composed mainly of hydrogen and helium, making it similar in composition to the Sun. The planet lacks a solid surface, its surface being a swirling mass of gases and clouds. Jupiter's atmosphere is both beautiful and dangerous. The iconic Great Red Spot is a massive, persistent storm that has raged for over 350 years. This storm is so large that 3 Earths could easily fit inside it. The winds in Jupiter's atmosphere can reach speeds of over 400 miles per hour, and the planet's magnetic field is 14 times stronger than Earth's, creating intense radiation belts that would be deadly to humans. But Jupiter's mysteries don't end with its atmosphere.
The planet has a staggering 95 moons,
many of which have their own unique features. Ganymede, the largest of Jupiter's moons, is bigger than the planet Mercury, and it may even have its own magnetic field. Perhaps the most intriguing of Jupiter's moons is Europa, which scientists believe may harbor a subsurface ocean beneath its icy surface. Could life exist in Europa's hidden ocean? This question has sparked a great deal of excitement in the scientific community, and future missions may provide the answers. Jupiter's gravitational influence is also profound. It acts as a kind of cosmic vacuum cleaner, capturing comets, asteroids, and other debris that might otherwise pose a threat to the inner planets, including Earth. Saturn, the jewel of the solar system. Moving outward from Jupiter, we come to Saturn, another gas giant renowned for its stunning beauty. Saturn's rings, composed of ice particles and rock debris, are the most spectacular in the solar system. These rings stretch out to over 175,000 miles in diameter, but are incredibly thin, just about 1 mile thick. Saturn has
146 moons,
with some of the most intriguing worlds in the solar system. One of the most fascinating moons is Titan, the second largest moon in the solar system. Titan is the only moon in our solar system with a thick atmosphere, and its surface is dotted with lakes and rivers, not of water, but of liquid methane. Titan's atmosphere is rich in nitrogen and hydrocarbons, making it eerily similar to what Earth's atmosphere might have been like before life evolved. Some scientists speculate that microbial life could exist in Titan's cold, methane-rich environment. Another moon, Enceladus, has been found to have water plumes erupting from beneath its icy surface, suggesting that there might be a subsurface ocean beneath the ice. Could life exist in these hidden seas? The discovery of these features has made Saturn's moons prime targets for future missions. Next, we journey to Mars, Earth's closest neighbor in the search for life beyond our world. Mars has captivated human imagination for centuries, and with recent discoveries, it has become the focus of both robotic exploration and human ambition. Mars is home to some of the most extreme geological features in the solar system. Olympus Mons, the largest volcano, towers nearly 13.6 miles, 22 kilometers high, 3 times the height of Mount Everest. And the Valles Marineris, a canyon system that stretches over 2,500 miles long and 7 miles deep, is one of the grandest features on any planetary surface. What makes Mars even more intriguing is its history of water, ancient river valleys, lake beds, and minerals that only form in the presence of liquid water suggest that Mars once had a warm, watery environment, potentially capable of supporting life. While the planet's surface is dry and barren today, with temperatures dropping as low as -195 degrees Fahrenheit or -125 degrees Celsius, at the poles, Mars may still have water frozen beneath its surface in the form of polar ice caps and possibly even in underground aquifers. But Mars is not only an object of scientific curiosity, it is also the prime candidate for human colonization. Its relatively mild day-night cycle, the presence of water ice, and its low gravity make it a viable target for future human settlements. NASA's Artemis program and private companies like SpaceX are working towards sending humans to Mars within the next few decades. Yet, living on Mars would not be without challenges. The thin atmosphere, lack of a global magnetic field, and radiation exposure make it a harsh environment for human habitation. The ice giants, Uranus and Neptune. As we venture farther out from Mars, we enter the realm of the ice giants, Uranus and Neptune. These distant worlds are unlike anything we encounter closer to the Sun. Uranus, the sideways planet. Uranus is unique among the planets in the solar system because it rotates on its side. While most planets spin on an upright axis, Uranus's axis is tilted by an extraordinary 98 degrees, meaning its poles experience long periods of daylight followed by years of darkness. This unusual tilt likely resulted from a massive collision with another object early in the planet's history. Despite its odd rotation, Uranus is a planet of striking beauty. Its blue-green color comes from the methane in its atmosphere, which absorbs red light and reflects blue. Uranus is a gas giant, composed mainly of hydrogen, helium, and water, with a faint ring system and
28 moons.
largely unexplored. Next, we encounter Neptune, the windiest planet in the solar system. With winds reaching speeds of over 1,500 miles per hour, Neptune's atmosphere is a violent and turbulent place. Its deep blue color comes from methane, which absorbs red light and reflects blue and green wavelengths. Neptune has a number of fascinating moons, including Triton, which is unique for its retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. Triton is also home to geysers that spew nitrogen gas and ice into space, hinting at a subsurface ocean. Could there be life beneath Triton's icy shell? This remains one of the tantalizing mysteries in planetary science. Exoplanets, worlds beyond our solar system. Leaving the solar system behind, we now enter the realm of exoplanets. planets that orbit stars beyond our Sun. The discovery of these distant worlds has expanded our understanding of the universe, showing that planets are common in the cosmos and that many of them may share characteristics with Earth. Over the last few decades, astronomers have discovered thousands of exoplanets using a variety of techniques, from the transit method to direct imaging. Some exoplanets are located in their star's habitable zone, the region where liquid water could exist just like Earth. These planets, often called Earth-like, have sparked the question, could life exist on these distant worlds? The James Webb Space Telescope, JWST, and future missions will allow scientists to study the atmospheres of exoplanets in greater detail, searching for signs of biosignatures, chemical signs of life. While we haven't yet found definitive evidence of extraterrestrial life, the discovery of so many potential habitable worlds has given us hope that we are not alone in the universe. Black holes, the cosmic enigmas. As we venture deeper into space, we encounter one of the most mysterious and mind-bending phenomena in the universe: black holes. Black holes are regions of space where gravity is so strong that not even light can escape. They are formed when massive stars collapse under their own gravity, creating a singularity, a point of infinite density and zero volume. Black holes are classified into three categories: stellar mass black holes, which are the remnants of massive stars; intermediate mass black holes, which have masses between stellar and supermassive black holes, which reside at the centers of galaxies, including our own Milky Way. In 2019, the first ever image of a black hole was captured by the Event Horizon Telescope, marking a monumental achievement in astrophysics. The image showed the shadow of a supermassive black hole at the center of the galaxy M87, located 55 million light-years from Earth. Despite their mysterious nature, black holes play a critical role in the structure and evolution of galaxies. They influence the formation of stars, the motion of galaxies, and even the flow of time and space itself. The study of black holes offers insight into the very fabric of the universe and the laws of physics that govern it. As our journey through the cosmos concludes, we are left with more questions than answers. The universe is vast, awe-inspiring, and filled with mysteries that challenge our understanding of reality. But each discovery we make brings us closer to understanding the nature of the cosmos and our place within it. The mysteries of space, the birth and death of stars, the formation of galaxies, the search for life on other planets, are not just the subject of scientific inquiry. They are the foundation of human wonder and curiosity. Our exploration of the universe is far from over. With each new mission, each new discovery, we move closer to uncovering the secrets of the cosmos. The journey is infinite, and we are only at the beginning.